Hey guys, we're on Unit 4, Day 4, and we're talking about translations. In a warm-up, it says points A and B lie on a line. The coordinate of A is -6. The midpoint of AB has coordinate of -2. What is the coordinate of B? So right here it tells us that we have a line segment, so we're going to draw a line segment. Call it A, B. And then it tells us that points A and B lie on a line. The coordinate of A is -6. The coordinate of, the midpoint of AB has a coordinate of -2. So we're going to go ahead and add in a point, call it M. So it's in the middle, it's midpoint, okay? And it's at -2. And also remember that a midpoint is in between two equal segments, okay? And they're asking for what are the coordinates of B. All right. Well, on the number line, in order to get from -6 to -2, there's 4 units in there. Okay. Therefore, there is also going to be 4 units here. Okay. So that those are equal distances from the midpoint to A and equal distance from the midpoint to B. Okay. So if you're at -2 and you have to go 4 units, where are you going to end up? So -2 plus 4 is +2. Okay. And therefore B is going to be at 2. All right. We're going to talk about translations in one sec. Okay, so a translation is a transformation in which each point slides a certain distance. And in the same direction. This distance and the direction of the translation is called a vector. Okay, a vector is created when joining a pre-image point to its image point. All vectors of a translation are the same length and parallel to each other. Okay? Notation, which we've already talked about, is a capital T. Okay? And there's 2 little numbers here, although they use letters to represent the numbers because we don't know what the numbers are. But the first number, okay, is going to talk about your left/right movement. Okay? And the second one, the B, is going to talk about your up/down movement. Okay, so the first one's always left or right. The second one's always up or down, just like our coordinates. Okay, our x coordinate will move us left and right and comes first. Our second coordinate, which is our y coordinate, will move us up and down, up or down. Okay. All right, so in this little text box here, it says in the diagram to the right, we have triangle A prime, B prime, C prime, and it's the image of triangle ABC. So this is our original triangle. And then there's some translation that slides it to the right and up, okay? Once it's slid to the right and up, if you look at these little line segments that connect your pre-image letter of A to the image letter A prime, and the same thing with B and B prime and C prime. And because we slid in that direction, there's little arrows there, okay, which makes those look like rays. But the arrow is just pointing the direction of the slide. All right. And those little yellow line segments with arrows on them, those are called vectors. Okay. And so it says in the diagram to the right, triangle A prime, B prime, C prime is the image of triangle ABC. Okay. That line segment that goes from A to A prime that I traced in yellow, B to B prime, and C to C prime, those are all going to be parallel. Okay. That's our parallel symbol. Notice all of those line segments are parallel to each other. Okay. And they're also congruent, meaning that they're all the same length, congruent, to the given vector. It says triangle ABC and triangle A prime, B prime, C prime are congruent. Those two triangles, everything about them is the same. They're all 3 sides have the same length as the original 3 sides, and all 3 angles have the same measures as the original 3 angles. And so the triangles are what they call congruent. Okay. And we'll talk about that more in the next unit. All right, coming down to number 1, it says in the diagram, to the right, triangle A prime, B prime, C prime is the image of triangle ABC after transformation. They want you to state the transformation that maps the triangle onto the other one. Okay, so what we're going to do is we're going to look at one of our pre-image points, let's say A, and we'll look at the image point. Okay, and in order for A to get onto A prime, we would have to move left or right. Hopefully you say left, and so we'll go left 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have to go to the left 8. So that would be a translation, since we're sliding, of left 8. Once we went to the left 8, now we have to go down 1, 2, 3, 4. So we'll go down 4. And that is perfectly a perfect way of describing that translation. We could notate it if we wanted to. And so that's part B. It says, how could the notation or the mapping rule of the transformation be written? The notation would be a big capital letter T instead of writing out the word translation. Going to the left is a negative direction. So we would say -8 since we went to the left 8. And down 4, down is also a negative direction. So we would write -4. Okay. When they say mapping rule, remember, always begins with X comma Y and then has this arrow, and it maps the coordinates onto what the translation is saying. So if you have an X coordinate, to move it to the left 8, you would subtract 8 from it. Okay? Comma, and then what do you do to the Y coordinate? You take your Y coordinate, and to go down 4, you would subtract 4. And there's our mapping rule. Okay? Part C is asking for any invariant points. Remember, invariant means didn't move. You didn't vary, you didn't move, you didn't change, okay? But if you can see, all of our ABC became in a different location, and so they did all move. So are there any points that didn't move? And the answer is no. Okay? They all moved to a new location. Part D says connect each pre-image point with the corresponding image point. So we're going to go ahead and say, if I connect A to A prime, B to B prime, and C to C prime. Okay, so part D said connect each pre-image point with the corresponding image point. So we just did that. And it says, what do you know about each segment you drew? Okay, all segments are two things. They're all parallel to each other, and they're all the same length, so they're congruent as well. Okay? And then part E says make the segments that were drawn in part D into rays that point in the direction of the translation. These rays are called vectors. So all we have to do is add a little arrow that says we were pointing in this direction. We slid B to B prime in this direction. Okay, we slid A to A prime in this direction, and we slid C to C prime in this direction. And now those line segments became looking like rays with the arrow, but in a translation, they're not really rays. They don't go really on forever and ever. They're just pointing in the direction that you slid. Okay, and that makes them vectors. One last thing at the bottom here. It says that a vector is a directed line segment. Okay? It's directed because it has direction based on the arrow. Okay? That has both size or length. Okay? And it also has direction. Okay, so it tells you not only how far to slide, hence the size or the length, but it also tells you the direction based on the arrow. All right. It says when identifying a transformation as a translation, be precise and state that it is a translation, and state the X shift, which is left or right, and the Y shift up or down. Okay. All right. We'll see you guys on the backside of notes in the next video.